Alright, hello everyone, it's December the 15th. Alright, let's do the challenge LCS. Wow, isn't this the one of the most iconic DP problem out there? Given two strings, return the length of the longest common subsequence. If there's nothing, return 0. Do you remember how to do this? I think I do. But let me think. We can do it. Yeah, if it's the same, then it will be the previous one, right? Plus 1. If they're not the same, then it will be the previous or previous. So let me see. We can definitely do this with two arrays, right? Two arrays. One array. Can we do this in one array? I don't think so. Let's do this in two arrays then. Man, I can't believe that we haven't done a oh no. 2021? No. Holy crap. We have some serious issues. No, this cannot be. No, we have 2022. Hold on. No, wait, hold on. No, it's right. I was scaring myself. Anyway, so that was scary. There we go. Thought we had a big mistake out there, but turns out it's fine. Okay. Let's see if I remember. DP is going to be oh, the length. Doesn't matter. We can just do text 2. Right? And then we're gonna start with all 0. Yeah, we can have 0 times len text 2. I think plus 1 will be easier. And for I in range, say len text 1. Right. So temp equals times len text 2 plus 1. For j in range, text 2. Okay. And we say if text 1 I is equal to text 2j, right? If these two are the same, then temp j plus 1, right, shall equal to 1 plus dp j. dp is the I minus 1, right? So yeah, because they're the same, it will go back up. Let's say else temp j plus 1 shall be the maximum of dp j, which is basically I minus, maybe just hold on, with ij, right? So it will be I minus 1j, which shouldn't that be j plus 1, and I j minus 1, and that will be temp j minus 1, so it will be j. And then we say dp will equals temp, and then we'll return. Let's see if I still remember how this one is done. Three. Okay, text 1, text 2. You know what? I feel like I've done this before, for sure. Not like specifically randomly encounter this problem, but just because I want to practice. You want to try one letter just to make sure everything works. Yeah, I've done it before. Yeah, it means I still remember how to do this. Still got it. Still remembered how LCS is done. Okay, so this is done. Let's go back to this. Well, this is not right. Now, I gave this problem a little bit of thought. So what I think is, of course, we want to swap with the values at position 0, because when we do this, we're having a free swap, right? That's what we have. But the issue we have with this test case is for the 4, right, to make swap in this cannot swap with 0. So the first thing this position can swap is this 3, right? So for anything that cannot swap with the front, so what I say is I'll just swap with the earliest thing, the first thing that I can swap with, right? Because that will be the smallest. So for all of them, I need to do this type of swap. And once I finish with all of them, then I can do the swap with the start. That's basically how I'm thinking right now, which means if I want to code it, for everyone, I want to check the front, right, and the side. I mean, we can also have current position for every single value. So basically what I'll say is we're going to have a dictionary. We can have indices. Okay, indices, we can have a dictionary. And then we're going to go through every single one, right? I'm gonna say for in enumerate nums1. Okay. So for each one, we just say we want to see if it can be swapped with 0. How do we do that? We say if it can be swapped, which means if it's, we say while, let's do j equals 0, right? We say while nums1 0 is equal to nums2. Alright, hold on. So I want to see if I can swap with 0. So I need to know nums2 0 is equal to n. Alright. We say if nums2, so the position here is equal to my current value. In this case, we have to move on. So if these two are the same, or the swap is useless, then say or nums1 0 is equal to n. So any of these is satisfied. I mean, but we start with 0, so it will always satisfy the first one. Hold on. Let's do it this way. We can say if n is not equal to nums2I, right? Then we continue, which means the current value and the nums2 are not the same, so we can just continue. So if they are the same, which means we need to swap. Then we check if I can swap with the 0 position, right? So we just need to know if 0 position is equal. If any one of them is equal, which means we cannot do, then j need to plus equal 1, which I just realized we need to put this as j. Okay, put this as j. Yeah, because the position we can swap with has to have different value on num1 and num2, and we start with 0. And then say if this is equal to, or this is equal to, which means we cannot, then we have to say j plus equal 1. If it's different, both are different, which means we can just do j, right? And j shall be indices.get n. So j plus 1, blah, 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 blah. Once we're done, j will be the first one that we can handle. All right, j will be the first one that we can handle. That's the indices. Now we say if so if j is not equal to 0, okay, which means j is larger than 0. If j is larger than 0, which means that position we actually have to do the swap. So now we'll just swap them. All right, if j is equal to 0, which means we can swap with 0, so I don't do it now. And if j is larger than 0, then I just say nums1 I nums1 j equals nums1 j and nums1 I. Right, we just do the swap. And after the swap, I will update, say indices n shall equal to j. Actually, it should be j plus 1 because that's the one. Because after I swap, I swap this value to j. So if the next time I encounter this has to be something further. Yeah, it makes sense, right? But it'll be easier just to say this is the current. Right, this is the current. So the next thing come in, if we have repeated, we don't have to go from the start again, which is always nice. Okay, so we go through this, so we do the very basic swaps, and then we're gonna go from right to left, and we just gonna do this. Everybody trying to swap with the front. Yeah, it's like what we do now is that we can all swap with the front. And what we're saying is if something cannot swap with the front, if I swap with the front, what if I cannot swap with the front? Now if we cannot swap with the front, it's already handled here. So everybody shall be able to swap with the front. And that's the thing. If I cannot swap with the front, maybe if I do some other trick and it will swap with the front. Huh. Actually, I don't know if this is gonna be the optimal. I really don't know. Yeah, this basically just say we do the most basic swaps, alright? The most necessary swaps, and then once we're done, and we go from the largest, we say, okay, we're gonna swap with these two, because we can, so we swap these two, and then we have to check. And what if the thing that's swapped will be equal? What are you suggesting? I honestly have no idea. I think what I'm suggesting is I'm gonna have keep a queue. Right, so we put this one in, and then we'll pop it out, And then to see if I can do, if I cannot do, I push it back in. I don't change. Check the next one. Okay. Is that a Q equals a list of a range line number one. Let's say while Q I go from front to end, doesn't matter. Then just say for I in Q, if nums I, nums 1I is equal to nums 2I, right? Then we see if we can swap. Yep, so if we can swap, and how do we tell if we can swap? Now the swap, we're only concerning, yeah, the swap will guarantee, right? So we'll guarantee that swap. So the current, these two are the same, right? And then we have guaranteed that this is not equal to this. So these two are the same. So nums 1, nums 2j equals this, or this could be the same. It doesn't really matter. Now j is where we're gonna swap. So these two values. And now this could be equal to this, or this equal to this, right? So these are handles, and now we have all these are different. So we want to swap. Yeah. I might have an infinite loop here. No, that's not possible because these two are different. And these two are the same. That's why I want to swap. And because when I swap, these two will be different. So the swap shall work. Right? And then moving on. So each time I want to swap, I just compare to, because nums 2 we don't have to compare. Nums 2 is always right, so just nums 1. So we just check with nums 1, 0. If they're the same, we push it back into the queue. We'll just try it again. Okay? So just saying, we say if these two are the same, right? Then we say if for whatever reason nums 1I is equal to nums 1, 0. So these two are the same, and then, which means I just cannot. I say or nums 1 I is equal to nums 2, 0. So we cannot swap to the front. Then temp.append I. Else, that means we can swap, then we will swap. Alright, we'll swap. Or make the swap. And then, because if we can swap, that means we'll be different. So we'll do the swap. And then we'll go on for the next one. I'll go on for the next one. So once we're done, we have a temp. Right? And then this temp will collect some values. Yeah. Then we say if Q is equal to temp, which means we didn't really handle anything, then we shall return -1. Otherwise, Q will equal to temp. And then we go on. And then we return rest at the end. Oh my god. I didn't mean anything. Huh. Ooh, wait, is nums1, nums2 the same size? Yeah, they are the same size. Ah, screw this. Do we have any line nums1? I can just swap them with n. Should be j is smaller than n. Nope. Oh. What does that mean? We go to the end. Which means, well, j smaller than n, and then we try to see if we cannot swap. So j plus 1 cannot swap. So we have a situation where we have nobody to put it. Alright, and then we just say if j is equal to n, which means we have no possibility to swap. Alright, and then we say okay. Hold on, I have all the test cases here. You know what? We'll use the small test case first. Nope, that ain't right. Ay. Nah, yeah, this is not the way to go. I don't know. I have to check the hints again. Yeah, let's do it tomorrow. I don't want to do it today anymore. Yeah, I'll leave this tomorrow. At least this idea didn't work. We have the hint again. Alright, see you guys tomorrow. Adios. Damn, that's still not working, huh?